Hello, everybody. So I have been introduced already, so I will start right away this presentation. And I will tell you a little story about myself. It was a few weeks ago. So how does it work? Yes? Yes. It was a few weeks ago. I was with some friends of mine. There was Jeremy. Sorry, too quick. There was Jeremy, Elon, Serge, and Pablo. Only guys. Sorry, it was a kind of bachelor party. And we had this discussion about climate change during the night. I don't know why. What a mistake. I mean, not about the climate issue. We were all aware of it. We knew about climate change, but the discussion went about the solutions. And then it spread in all the directions. So, for instance, Jeremy, he only talks about renewables. Elon is keen about technological breakthroughs. Serge, he wants degrowth. And then Pablo, well, Pablo, he says that we are all going to die. So I will tell you a bit more about this discussion, and I will tell you how it ended in a dead end and how to get beyond this dead end. And in order to be able to tell you more about this discussion, I need to introduce you one mathematical tool that is called the Kaya identity. And it's a very powerful tool to think about the energy transition. So the Kaya identity is about CO2 emissions. So it starts like this: CO2 equals CO2. Do you agree with that? Okay. And then you multiply and divide by the same term, like energy, GDP, and population. And when you have done that, you get 4 different terms, and each of them has a specific meaning. So, for instance, the first one is what we call the carbon intensity of energy. It means how much CO2 it emits to produce 1 kilowatt hour of energy. Easy. The next term is the energy intensity of the economy. So that is how many kilowatt hours do I need to make 1 point of GDP. Then you have the GDP per capita, which is behind the notion of economic growth. And you have the population. So it's a good news because now the CO2 emissions are a multiplication of 4 different terms. And if you want to decrease them, then you just have to decrease one or several of these terms. So, for instance, you can play on the first one. You can decarbonize the energy. One way. You can also decide to work on the efficiency. You can decide to degrow. And you can also decide to kill everybody, which solves the issue. But we are not going to do that. So we don't kill anybody. So there remain only 3 terms. We can decarbonize, we can improve the efficiency, and we can degrow. But my friends, Jeremy and Elon, don't really like the idea of degrow. They say we can do some decoupling. So what is decoupling? Decoupling is when you have an increasing GDP in a world that is decreasing its CO2 emissions. Well, Pablo and Serge, they don't really agree with that. They say that it never happened and it's never going to happen. So what we need to do now is, I will tell you the following of this discussion. I will give you a few indications of the role of each term of this equation in the decrease of CO2 emissions. We'll see. That is what happens during 1 decade. So you see the different colors: population, GDP, efficiency, etc. So that was between 1980 and 1990. And if you look at the next decade, it's the same, but every time it increases. So we have increasing CO2 emissions, unfortunately, for decades. Now, what happens if I sum up all these 4 decades? Then I have this graph. And here we go. So it's going well, it's too big. I need to change the range, to zoom out, and to be able to see it. What you understand is that we do improve the efficiency for a long time, but it doesn't help to decrease the CO2 emissions because they always increase. What happens when we improve the efficiency is that it allows us to have more growth. So that's what we clearly see on this graphic. Okay, so what do we do with that? During that discussion the other night, we took the Kaya identity from the left to the right. And that is what led us into this dead end. So let's do it. Let's have this discussion. First, what about CO2? What do we need to do to stay below 2 degrees? I don't know if you know about the figures, but we are here and we need to go down to here, which means that we will need to divide by 3 the CO2 emissions during the next almost 3 decades. So between now and 2050, we need to divide by 3 CO2 emissions, which means that we need to do minus 5% per year as of now until the end of the century. So that's globally speaking. Worldwide, we need to decrease by 5% a year. But of course, it's not going to be the same deal in developed countries and in developing countries. So we will not ask to developing countries to decrease their emissions by 5% a year. Of course not. They will need to have some space to develop. And it means that in developed countries, we need to do much more. So what is the target for developed countries? Maybe you heard about it. It's carbon neutrality by 2050. So what is carbon neutrality? So some people think it's, so what means net zero? Some people think that it's when your emissions are compensated by an offset project. So I emit CO2, but I pay somebody in another country or another company to run a project that will spare some CO2 somewhere. If you add up the whole thing at the global level, it doesn't work at all. So it's one way of counting things, but it's a way companies want to talk about net zero, but it's not the right definition. If you are a country and you negotiate at the COP, the next COP, for instance, then you want to take this definition. My CO2 emissions are offset by my own natural carbon sinks, my forest, if not my oceans, my part of the ocean. And it's still not the right definition to talk about carbon neutrality. What is really taken into account by IPCC is when anthropogenic CO2 emissions, our emissions, are compensated by anthropogenic negative emissions, anthropogenic carbon sinks. It means, for instance, carbon capture and storage. This works. Or reforestation or afforestation. This will be able to count. But it's a very limited capacity. Carbon sequestration has a very limited capacity, whatever the technology we use. So that's, well, just a little briefing about what net zero means. Anyway, it means that we will, in the end, we will need to decrease our emissions by 5% a year at the global scale as of now. To talk more about the net zero target, I want to emphasize this point. We are here and we need to reach this part, and the vertical axis is the net emissions. So the positive minus negative emissions. And the point is, do we follow this path or this one? If we follow the lower one, it seems to be okay. We'll be able to stay below the 2 degrees. But in fact, if you choose to follow this path, and you see visually that it emits much more CO2 in the end, and most of all, it also means that you will make the effort at the end. And I don't want to be in the shoes of the people who will try to do that, because it's a nightmare. So just talking about carbon neutrality with a very, very long-term target, it's well, it's kind of bullshit. As long as you don't tell what is your path in between. So it can be this one, it can be maybe this one, but still you need to tell also what path you're going to use between now and the end of the story. So that was about carbon neutrality. Do you know about the carbon budget today? Which part of the carbon budget we have already used? So in fact, it's we have used most of it. This is historical emissions, and this is what remains to be emitted if we want to stay below 2 degrees. So it means that we have already used 2/3 of our carbon budget. So it means the degrowth in CO2 emissions need to be much quicker than the growth that we had before. So that's all about these -5% a year. And as I told you, we're going to take the Kaya identity from the left to the right, starting from the left. And the first reaction would be to say, if I want to decrease that, I just need to decarbonize the energy. The first reaction. And that's precisely what my friend Jeremy always says. He talks about renewables. And I had to show him this graph. And I told him, look, Jeremy, excuse me, I skipped this. Look, Jeremy, this is the global energy production and consumption of the different energies. So you have the 3 fossil fuel energies. And at the top here, you see the nuclear and renewables, so the decarbonized energies. And I'm obliged to zoom in a lot to show you these things. And then I took a pencil and I drew these 2 little triangles. And you see they are exactly the same shape and size. It's okay. And what do they represent? The height of this green triangle represents the CO2, the renewable production during 1 year, the yearly production in 2017. And the height of the red one represents the increase in fossil fuel production over 18 months. So what does it mean? It means that all the efforts that we have made during decades, I mean, from the beginning of the 19th century, we have installed dams, windmills, solar panels, all these things. All these efforts are kind of washed away by 1.5 years of increase in CO2 production. So, of course, we need to do some renewables, but it's not enough. So at this moment, our friend Elon said, yes, but you forgot about the nuclear, because Elon, he loves nuclear. So I said, Elon, okay, look, I will add nuclear if you want. It's still the same thing. You have these 2 triangles, and you see the decarbonized energy, so nuclear plus renewable, in 2016 equals the increase in fossil fuel production over 3 years. So still the same conclusion. Of course, we need to develop decarbonized energies, but it's not going to be enough. So the conclusion is we also need to decrease the consumption of energy. For instance, with energy efficiency. And that's what Elon loves. So he talks about hydrogen, about blockchain, about self-driving cars and things like that. And he's very enthusiastic about that also. His enthusiasm is contagious, and we really we were really listening to him. And then Serge, the other friend, said, okay, guys, energy efficiency is not new. It's something we do for decades, probably since the beginning of the Industrial Revolution. And we improve the efficiency by 1 to 2% a year for decades. This has been calculated. So only 1 to 2% a year, while we need to do -5 in a world where the population and the economic growth are increasing. So it's not going to be enough. And then Pablo said, not only it's not going to be enough, but on top of that, when you improve the efficiency, it means you improve the system, and then the system will accelerate. And by the way, this system is heading to a wall. so it will crash even sooner, and we're going to die even quicker. Thank you, Pablo, for your enthusiasm. And then Serge said, hey, Pablo, that's precisely why I advocate degrowth. So we made a little survey in the restaurant where we are. We asked to the people who want degrowth to stand up, and nobody did. So we said, Serge, you see, Pablo is right. We are all going to die. So then we won't stay here. In fact, that was the dead end in which we ended up and that night. And now I'm going to tell you how to go beyond that. To do it, we will need to break the Kaya identity, and then to repair it and take it not from the left to the right, but from the right to the left. So first of all, can we break a mathematical equation? Normally not. But today, only for you, I will do it. Okay, so I will break the Kaya equation. So how do we do that? To do that, I will project the Kaya identity into several sectors. I will start with the transportation sector. So to project the Kaya identity in a sector, I take the GDP and I replace it by what this sector provides. What does the transportation sector provide? It provides kilometers. Okay? And when we do that, we see two new terms appearing. Here we see something related to the efficiency of the vehicle, how many liters for 100 kilometers. And you also see here the transportation needs, how many kilometers people need to do per capita. Okay, we agree with that. Except that here lies the problem. It's not exactly the same kind of kilometers. On one side, it was the kilometers traveled by the vehicle, and on the other side, it was the kilometers traveled by the people. So our Kaya identity is broken. We made it, we broke the Kaya identity. So now we need to repair it very quick because it's very dangerous to have a broken identity. And then you see, I repair it by just adding the missing terms. And what do they represent? What is the difference between the kilometers traveled by the car and by the people? Well, it depends on the number of people per car. So we have introduced the fill rate. And that's very interesting because now we have one new term on which we can try to do what we call the decoupling. We want to decrease that and to maintain this and this. So if we improve the fill rate, then we will decrease the CO2 emissions. If you put twice more people per car, or you put them in public transportation instead of cars, then you decrease the CO2 emissions of this sector. And it's very powerful. It's going to be much more powerful than just trying to increase the efficiency of the engine, which you will be able to improve by 1 or 2% a year. Okay, so let's do it with another sector. Here I have industry. What does industry provide? It provides items. Okay? It will manufacture stuff, things. So we see two new terms appearing. Here is a gray energy. How many kilowatt hours do I need to produce this object, for instance? And here you have the equipment rate, how many items per people. But is it exactly the same number of items? Not exactly. On one side, you have the items produced every year. And this production needs energy and it emits CO2. And this is the stock of the items owned by the population. And it's a stock. So what's the difference between the two? So again, we have broken the Kaya identity and we will repair it by adding what is missing, which is the lifespan of products. If I increase the lifespan of this product, it means we will need to manufacture twice less to have the same equipment rate. And again, it's very efficient because we need to have this kind of decoupling things in order to decrease the CO2 emissions. So the more terms we have in the Kaya identity, easier it is to reduce the final emissions. So that was about industry. Now, what about food and agriculture? Well, we take the Kaya identity and some technical adjustment. We will replace CO2 by greenhouse gases, because agriculture is not only about CO2, but mainly about methane and nitrous. And we also change energy with the surface, because the notion of energy in agriculture is the number of hectares that you have to gather the energy of the sun. And then what do I replace GDP with? I replace it with the kilograms produced by agriculture. Okay, and here you see a first term that is related to the agricultural yield, and another one which is the need for food per capita. So, is it exactly the same quantity of kilograms? Not exactly. On one side, you have the kilogram produced. On the other side, you have the kilogram consumed. Can you consume a kilogram that has not been produced? Of course not. But can you produce 1 kilogram that will not be eaten? Yes. And that's 30% of the production is wasted. So the difference between these two notions is the quantity of losses between the two. So production and losses. And now we will be able to play on this part, which is 30% of the total production. And it won't cost a lot. I mean, it's a question of organization. You need to put more processes in place, but it's just a question of producing things that we will really consume in the end. So we have a way to work on this part. And about agriculture, we can go even further than that. I will take the Kaya identity and I will project again in the Kaya, in the sector of agriculture. So let's do it again. I change again CO2 with GHG, energy with surface, and I change GDP with calories. Now we don't talk about kilograms, but we will be talking about calories. Okay, and it's always, as always, it's not exactly the same calories. The one that are produced, the one that are consumed, and sometimes we produce calories. We produce cereals, etc., and we don't give them to humans. We give them to animals that we bred in order to eat them later. So if you make the calculation, you introduce a notion that is a metabolic efficiency of the animals that we bred, and these animals have a quite bad yield, in fact. I will give you a few figures. For instance, you see here that you need 12 vegetable protein in order to produce 1 protein of meat when it's about beef. You need 25 vegetable calories to make 1 calorie of beef. If it's about chicken, it's much less because it's a smaller beast and it has a better yield. So the smaller the beast, the better the yield. And that's the reason why chicken is better than beef. Pork is better than beef. Chicken is better than pork. And insects are even better than chicken. So here you see we have introduced one new term in the Kaya identity, which is the metabolic yield of the animal. And then if we choose one or the other, it changes radically the CO2 emissions in the end. A few more graphs to convince you with that. You see here the different kind of food, and you see the land use per production. The land use in order to produce 1 kilogram of lamb or mutton, beef, cheese, etc. And you see the very big difference between beef and other animals here and the rest. So it means the day when we have less surface available because of climate change, for instance, or things like that, then we will really need to think about how do we use this surface in order to be able to still feed everybody on Earth. And that's another graph with different notions. You see the part of land use, farming, animal feed, processing, transport, etc. And you see that most of the of the issue comes from land use and farming, and not about the packaging of your beef steak. It's not the issue. The issue is about the methane of the animal, and also all the food that it ate during his life. So that's to make a conclusion about food. When we talk about food, the most important things are to have a more a regime with more protein from vegetables. Maybe become a vegetarian. At least eat less meat. So we know why it's important. We also talk about organic food. Does not really impact on climate, but it's a question of health, and biodiversity. So for other reasons, it's a good idea to eat organic food. Then we talk about local food. Why? Because it avoids transportation. And we also talk about seasonal food. Why? Because it avoids heating the house, the greenhouse. Then maybe one last point about agriculture, but about food, is the role of marketing. And that will be a topic for your debrief of the Climate Fresk in 2 hours, once you have finished playing, doing the Climate Fresk. So here is where we stand with my friends during that night and our discussion. And I told you that we wanted to break the Kaya identity and repair it in order to go beyond this dead end of this discussion that we had. So this is, again, the general form of the Kaya identity. And here you see the efficiency of the economy and the needs per people. And in fact, I will replace GDP with 2 different notions. Sometimes GDP represents the industrial production. And this production uses energy and emits CO2. And in other cases, GDP represents what the economy is delivering in terms of services to people. What needs are met by the economy. So I changed GDP with these 2 notions, production on one side, needs on the other side. And then we have broken the Kaya identity again, and we repair it by adding the missing terms. And these terms, I will call that the term on which we can do some real decoupling, because you can go very far by, increasing the lifespan of the product, by also to mutualize the products, to have more people using the same item, to sell them and to go for second-hand products, etc. So all these things were not appearing at the beginning in the Kaya identity. Why? Because they were hidden in the notion of GDP. And GDP is not a very good indicator. So it has flaws. And this decoupling potential was hidden in the flows of the GDP as an indicator. And that's why I needed to break the Kaya identity, to repair it, and introduce one new term, which will give us much more hope. So now it's time to give you hope again. And we take the Kaya identity not from the left to the right, but from the right to the left. So let's go. Population. We're going to be 11 billion at the end of the century, more or less, whatever happens. Most of the countries have already went through their demographic transition. Most of the countries on Earth have come to almost 2 or a bit more than 2 kids per woman, except in a few countries in Africa, but most of the countries have done it. So most of the population is very young, so they will grow up and it will increase the population, but it will be stabilized by the end of the century. So there's no way to panic about population. It's going to be stabilized. Then we have the term about the needs. And here I have to admit that I kind of agree with my friend Serge, the degrowing guy. I kind of agree with him when he says that we need to rethink our way of life. He says, we developed countries, we tend to make a confusion between our greed and our basic needs, our desires and our basic needs. And especially in a world that has a limited carbon budget, Satisfying our desires will be at the expense of the basic needs of other people somewhere else on the planet. So that's a fact. We just need to be aware of that and to think about, why do I really need? Do I really need to buy this stuff? Do I really need to consume that? And just think about it. That's the first step. It's an individual, question. It's a philosophical, political question, but it will start by that. Then, once you have questioned your way of life, then you can also try to make some improvements globally by, for instance, by mutualizing objects. Imagine that you organize a WhatsApp group with your neighbors in the whole building in order to share a drill, some tools, some materials that you really don't need very often. You will use them once a year or less, and then you mutualize with your neighbors, and it's a very efficient way to have the same standard of living with less objects and less production. So then we go on with improving the energy efficiency, but at the same rhythm as before, 1 to 2% every year. We will not make any miracles, but we'll go on the same way. And I give you an example why it's important to do that before decarbonizing. If you, for instance, if you make a refurbishment of your house, and imagine you need to make the thermal insulation and to change the heater. What do you do first? I advise that you first change, you first do the thermal insulation, and once you have divided by 3 or 4 the energy needed to heat your house, then you change the heater, because you will buy a smaller one and it costs less. So it's more logical to do it this way. And once you have reduced the energy need globally by doing all these things until here, once you have done that, you will be able to, so you have reduced the need for energy, and look what happens on the global, at the global scale. Here is the worldwide production of energy. On the horizontal axis, you see the quantity of energy produced and consumed. On the left, you see the decarbonized energies, nuclear, renewables. Then you have gas, oil, and coal. And at the far right is the most carbonized energy. On the vertical axis, you see the carbon intensity of energy. Remember how much CO2 it emits to produce 1 kilowatt hour of energy. So the answer is 250 grams of CO2. And now imagine that we manage to divide by 2 the quantity of energy needed worldwide. Which part do you think we will keep? Do we keep the left part or the right part? Of course, we are not stupid, so we keep the left part. And look at what will happen if we first get rid of the most carbonized energies. They will disappear, and here you see the emission factor that will be improved by 30%, just because we have first get rid of the most carbonized energies. And we did not even install more solar panel or windmills, nothing of the kind. We just renew them. Of course, we can do more. We can try to have more of them, but just by keeping what we have, just for you to understand the principle, we just keep what we have, we renew them when needed, and then we just gain 30% by just because we have reduced the energy consumption first, and we have started by getting rid of the most carbonized energies first. So now some figures about what could be done between now and 2050. We start with a basis of 100 here, and we will add population, and the population is going to be plus 25% by 2050. That's by the UN scenarios. Then let's say that we have a progression here of the needs, so not in developed countries, because we will try to reduce our needs and at least our desires, and to really think about our real needs. But for developing countries, it's important to have some space to develop. And that's the reason why I keep something positive here, to say that we have some hope, and during over the next almost 3 decades, this term will progress at the global scale. And then on this term, we do a factor 2, because, you know, it's about improving the lifespan of the object, about sharing objects, about going for a second hand, etc. Something we don't really do today. So just a factor 2, and we have almost 3 decades to do it. I think it's feasible. And then we go on with energy efficiency, and we go on the same rhythm as before, between 1% and 2% a year. So no technical miracle. And then once we are here, we have already divided the energy consumption by 2. So we have this bonus that I told you about. And here we are. We have managed to divide by 3 the global emissions by 2050. So it's feasible, but it's not going to work by itself. Here you have the CO2 at the end. And if we let the economy work at it as it works today, look at what will happen. It's going to be a rebound effect like before. Even this way of making some decoupling is going to be to make some rebound effect. So if we want to keep CO2 lower, we need to put a lot of pressure on CO2 with the carbon price, with norms and regulations, etc. And it will not be done by itself. It has to be regulated. We need to ask to the politics to make some regulation of the economy. Otherwise, it won't work. It will just won't work. So the economy is a bit like a big system, and we don't really understand precisely how it works. And what we need to do is to put a carbon price at the border of the system, outside the system. And then we put this carbon price pressure on the system, and it will reorganize itself. Don't ask me how. It will just reorganize itself. People are intelligent. People are innovative. They build startups like you did, and they invent new products. So some industries will disappear. Some companies will go bankrupt. Some other will start. And look at what happens when you put this carbon price on the economy. The economy will rearrange itself. I don't know why. I don't know how it will be. It will do that, but it will. It will rearrange itself, and then that's the way we will be able to manage to reduce CO2 emissions. So it's a question of playing on these different terms of the Gaia identity, and sometimes it's going to be producing some renewables or low carbon energies, and it will have a cost. It will cost X euro per CO2, per ton of CO2 avoided. And that's something we need to calculate. In another case, it's going to be to install a drive on an engine, and it will save Y euro per ton of CO2 avoided. And in another case, it's going to be mutualize my car with some friends, and it will cost almost nothing in terms of euro per ton of CO2 avoided. And in some other cases, it's going to be just destroying the demand. I will not buy this thing because I don't need that. So it's another way of doing things. And all this way of reducing the CO2 emissions will be complementary. They will add up. They will even multiply themselves. But they will also be in competition. And if you have to choose between two different projects, just look at the quantity of euros per ton of CO2 avoided, and let the better win. The economy works like that. It's a fact that we work in a liberal economy, and in a liberal economy, the winner are the best. So just see which of these projects will be the most powerful, and that's how we will be able to manage the transition. And personally, I will rather bet on this kind of solutions rather than on this one. It doesn't mean we will not need energy, decarbonized energy. It just needs that we want to keep the population alive. We want to improve the needs per people. And for that, we will start by, so first in developed countries, we will first start by challenging our way of life. then decouple, make some decoupling on this term, and then go on improving the efficiency. And at last, there is still energy needed to run what remains to be produced, and we need to decarbonize this energy. But once we have reduced it, and that's how it will be able to do things. Thanks for your attention.